Well, this is John Black, super chemist. We're going to talk about simultaneity. Keep in mind, I used to believe in this stuff. I used to believe in this simultaneity thing till about a week ago. I believed in all this crap. Right? Before we start, I want you to understand what. Okay, you're on Earth, right? And these two lightning bolts come down. They hit the ground at the same time. The photons are going to go. He's going to say, these lightning bolts hit the ground simultaneously. That's simultaneity. But let's say this rocket ship is flying by, right? And right at this second, right, where he's right here, the lightning bolt hits the ground, right? This guy will still say simultaneity. They hit the same time. But what about this ship? If he's right here when it hits the ground, that means photons started to leave right there, right? And by the time that this lightning photons got to the ship has moved. And it's moved into these, right? So it appears on the ship that, this is happening before this, right? So they aren't simultaneous to the guy on the ship, right? But this is just an optical illusion. We can all see and say that the freaking lightning hit the ground at the same freaking time. He's moving towards this photons and away from these photons, okay? It's not magic. They're not in different universes. Time didn't go wibbly wobbly, okay? It's just he's driving into these photons and driving away from those photons. Obviously, he's going to perceive these to happen first and these to happen second. It's not that time is, there's different clocks and blah, 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 okay? But why is it relative? Remember what we did with the lightning bolts. It's relative because if you're moving, you'll get information in front of you first and information behind you last. So it will appear, it will be a perception that things in front of you are going faster than things behind you. But it's just a perception because you're moving into the things that are in front of you with your velocity, and with your velocity you're moving away from the things that are behind you, okay? Nothing contracts, okay? It doesn't contract in between you and the lightning bolts on the direction you're going. No, it doesn't contract. No, you contracted it, okay? You made the distance smaller by moving into the lightning bolt on the right. The universe did not contract. You contracted it. You moved over. Okay, so let's get into simultaneity, right? You have these three guys, A, B, C. They're just standing still. Don't look at those numbers or anything. They're just standing still. They got their clock set at 3 o'clock, and as soon as it hits 3, they're going to hit their flashlights and send some photons towards this guy, right? All of them, the photons are going to bounce back. Photons are going to bounce back. They're all going to agree that B, right, he got hit with them photons, and all the photons were traveling into C. Okay, they're all going to agree. Okay. The problem here that we have, right, it's just like down here on the rocket ship, right? What if these people are moving at half C, right? Now we know there's no physics experiment you can do to prove what constant speed you are at in all inertial frames. I mean, without looking out the window, right? You can't, nothing's standing still, right? Everything's moving. So we're all moving at constant velocity, right? But there's no way to prove what constant velocity, right? Because all physics experiments all give you the same results in all inertial frames, right? Where you're at constant velocity. But see, that's the problem now. What if you add in a third person, right? Velocities are fundamentally relative when comparing inertial frames. Let's say this person is floating in outer space, right? He's just inertial, just sitting there, not moving at all, right? Now, these people fly by, right? At the same exact time that they're in this configuration, right? These two people, A and C, they do their flashlight, right? The beam goes, and obviously it has to do the same stuff, right? It has to hit him at the same time, or he has to at least perceive that they hit him at the same time, right? And the problem is, if these beams are going C relative to these three men that are moving it at half C, that would mean this photons relative to her, it would be moving at c, right? Plus this half a c, so that would be c plus v. And this way, right, if the photons are moving at c relative to everyone on here, and they're moving at half a c, then that means it's moving that way at c minus this velocity, minus v. So what's the deal there? is the whole problem, you know what I'm saying? The D, okay, can't see, supposedly, that light goes faster or slower than C. But she would see that the light goes faster on this one and slower on this one, right? So let's see what they're going to tell you, their lies. Okay, and they're pretty obvious too. This is what makes me so mad that I believe this crap, because, you know, it's just so obvious. I went into these things with the Minkowski diagrams and stuff like that. I bypassed these common sense things that they were doing, these thought experiments. If I would have, so I went into it thinking it as math. That's the wrong way to do it. These people, they got this 4D math crap up there. They're trying to jam it right down physics throat. You know what I mean? But you can't do that. That's not how science works. He named all of his people instead of just giving them A, B, C, D. Okay, so if he says Alice, that's A. If he says B, that's Bob, Charlie, and I think Dave or something. I don't know. This guy's channel is called More in Depth. Relativity of Simultaneity. Don't skip this effect. Yeah, let's hear your woke lies.
To understand her perspective, we need another ingredient here. It's provided by Maxwell and added in by Einstein, the laws of electrodynamics. Namely, they're insisting that the speed of light be a constant and the same constant no matter what. So you would have seen these epsilon and mu constants in the laws of electrostatics like Coulomb's law and the Biot-Savart law. These are fundamental constants of space that quantify the strength of electromagnetic fields, how they penetrate space, if you will. So if you write down the Maxwell equations just for a vacuum...
You notice how he keeps saying these, I don't know what that, I think that's permittivity of space. I'm guessing that's permeability or whatever of space, but they're both constants, or you know, they're describing space, going through space. Okay, nowhere in this equation do I see anything about human feelings, human emotions, being relative to humans, the speed of sound relative to humans. I see him saying relative to space.
They will still be there. If you write all four of the Maxwell equations together, you get to these second order forms, and these equations obey a wave equation in 3 dimensions. That is what describes an electromagnetic wave. This is light. So the wave equation then requires for the propagation speed of the wave, so light, to be 1 over the square root of these 2 constants.
Yeah, the speed of light relative to what? To what? Space. Oh, and these MO, subscript O, and E subscript O, those are, traits of space. Oh, so he's saying, and he knows, he admits that this speed of light says that you have to go that speed of C through space. He admits, he knows it. It's relative to space itself. Okay, he knows. He admits it.
Again, they are fundamental constants of space.
They are
laws of physics. So they're not going to change because you're on a train.
Yeah. See, this right here, this is a universal postulate, see? See, and the universe doesn't give a crap about Einstein. He don't give a crap about his postulates. He don't give a crap about your perception in your frame, okay? He only cares about his own postulates. Okay, that's the number one thing these physicists seem to forget, okay? The universe already has postulates, okay? And it ain't going to change because of your opinions or your feelings or your frames of reference.
Now, This equation in yellow says that it is a law of physics that the speed of light be exactly this constant.
Relative to
And
space.
so the speed of light has to remain invariant through inertial reference frames.
Yes, it must stay at C in every inertial reference frame. Every one of them, it's going C. Okay? Relative to space-time, not relative to you. Okay, this idea that the whole solar system revolves around you on Earth because you are so human-centric, okay? No, it doesn't work that way. Physics doesn't revolve around your feelings, okay? It revolves around this fact that light goes through space at c. And that's a universal postulate, not an Einstein postulate. You cannot change that.
So even though the train is moving forward with velocity v, when the flashlights are turned on, Denise won't measure the light beams moving with velocity c plus v or c minus v. So, with that, we now have the two postulates in place. These are the postulates that Einstein used to build relativity.
So what are the two postulates he's talking about? The first postulate, he just did a whole bunch of equations showing you that relative to space, it doesn't matter what you're doing, how fast you're going, how slow you're going, always light is going to move at c relative to space-time. This is a universal postulate, not a Einstein postulate. And what's the second one thing? Oh, there's no physics experiment that you can do to prove you know what constant speed you're at in all inertial frames, right? Okay, well, I'll go along with that. I agree with that. There's no experiments results that you can I agree.
The classical principle of relativity, as we have invoked already, and the constancy of the speed of light. Equipped with these, we can now analyze Denise's point of view, and we will draw the conclusion that simultaneity is relative. As we've agreed...
But why is it relative? Remember what we did with the lightning bolts. It's relative because if you're moving, you'll get information in front of you first and information behind you last. So it will appear, it will be a perception that things in front of you are going faster than things behind you. But it's just a perception because you're moving into the things that are in front of you with your velocity, and with your velocity you're moving away from the things that are behind you. Okay, nothing contracts. Okay, it doesn't contract in between you and the lightning bolts on the direction you're going. No, it doesn't contract. No, you contracted it. Okay, you made the distance smaller by moving into the lightning bolt on the right. You didn't. The universe did not contract. You contracted it. You moved over. Jesus.
Already, Bob receives the pulses simultaneously as before. However, in Denise's perspective, Alice's light pulse moves in the same direction as the train is, while Charlie's moves in the opposite direction, while Bob is moving along with the train. So Denise measures that Bob has different relative velocities to both of these light beams. He moves towards Charlie's pulse, so that's c plus v, and away from Alice's, so that's c minus v. It is correct to add the velocities this way, since both of the velocities are measured by Denise from another frame. So, these light pulses will take different amounts of time to arrive at Bob, all as seen by Denise. We can calculate by how much, so call TAB the time it takes for Alice's beam to arrive at Bob. That is going to be L divided by the relative velocity here, which is c minus v. For Charlie to Bob, Denise measures that it would take different amounts of time for the beams to reach Bob. She still has to see both of them reach him at the same time. That is physically what happens. They have to agree on that. For example, imagine that...
Keep in mind, if they're going like at half c, this person right here, once they get to this point here, that's like 0.000000003 seconds.